What you're watching is a live demonstration of a custom Python-based PDF data extraction and Excel automation system. This application was built to process complex, multi-page shipping invoices and automatically transform unstructured PDF information into clean, structured, and analysis-ready Excel data. For confidentiality, this demonstration uses completely synthetic data. No real client, customer, or shipment information is shown. This is not a standard PDF to Excel converter. The system uses custom extraction and processing logic to identify different types of information within complex invoice documents, associate related values with the correct shipment records, clean the extracted data, and place each value into its appropriate Excel field. The interface was also designed to visualize this entire process in real time. On the left side of the application, you can see the source PDF. On the right side is the live Excel output. At the top, the application reports the current PDF, page number, Excel row, extraction status, service category, and other processing information. At the bottom, the live activity log shows what the extraction engine is identifying and writing to the workbook. Now the automation is processing the document page by page. As shipment information is detected in the PDF, the corresponding values are extracted and mapped into the structured Excel output. Instead of simply copying text from a PDF, the software determines which values belong to which records and which Excel columns they should populate. This distinction becomes especially important with large invoices containing many shipments, charges, credits, surcharges, reference numbers, and other billing information. Here you can see the extraction happening at the field level. Information such as shipment references, service details, zip codes, zones, weights, published charges, incentive credits, billed charges, and additional fees can be processed as part of an individual shipment record. The live highlighting provides a visual connection between information in the source PDF and the structured values being written into Excel. This makes the extraction process easier to inspect and verify. Real-world invoices are rarely perfectly uniform. A single document may contain summary pages, shipment details, adjustments, service charges, credits, incentives, reference information, and other sections. The automation therefore has to understand different record structures rather than assuming that every page contains the same type of table. Custom parsing rules are used to determine what information is relevant and where that information belongs in the final dataset. Extraction is only one part of the workflow. The captured values also need to be normalized and mapped into a consistent schema. For example, monetary values need to remain associated with the correct charge type. Shipment level information needs to remain grouped with the correct record, and different invoice sections need to be represented consistently in Excel. The objective is not simply to extract text. The objective is to produce structured data that can actually be filtered, analyzed, reconciled, and used in downstream business workflows. At this point, you can clearly see both sides of the process operating together. The original PDF remains visible on the left, while the structured Excel representation is built on the right. The application continuously reports the page and destination row being processed. This synchronized interface was designed both for monitoring and for demonstrating how individual source values are transformed into structured output. A major reason for building custom automation like this is scale. Manually reviewing large invoice documents and transferring individual records into Excel is repetitive, time-consuming, and vulnerable to human error. A purpose-built extraction pipeline can repeat the same processing rules across hundreds or thousands of pages while maintaining a consistent output structure. The same architecture can also be adapted to process batches of PDF files rather than a single document. The workflow goes beyond basic text recognition. Different pieces of information can have relationships with one another. A charge may belong to a particular shipment. A surcharge may need to be associated with the same tracking record. An adjustment may appear in a different section of the invoice. These relationships have to be preserved when transforming the source document into tabular data. This is why complex document automation often requires custom processing logic instead of a generic PDF conversion tool. Once the information has been extracted, the result becomes much more useful than the original document for data analysis. Structured Excel records can be filtered, sorted, searched, compared, reconciled, or imported into another system. Large volumes of invoice information that would otherwise require manual review can therefore become a reusable dataset. The goal of the automation is to bridge the gap between human-readable documents and machine-usable structured data. The system continues processing the document automatically while maintaining the relationship between the PDF source and Excel output. During this part of the demonstration, notice that the application requires no manual copying and pasting of individual records. Once the input document, Excel template, and output location are provided, the extraction workflow can perform the repetitive processing automatically. This allows human effort to be focused on review and exceptions rather than manual data entry. The extraction is now approaching completion. After processing the required pages and records, the application creates the final Excel workbook. The output is not limited to a single flat table. Different categories of information can be organized into dedicated worksheets so that summary information, invoice-level data, shipment details, fees, and other extracted records remain logically separated. Here is the generated Excel workbook. You can see that the extracted information has been organized into multiple structured worksheets. The workbook includes summary and reconciliation information along with detailed invoice and shipment-level data. Instead of searching through a large PDF manually, the resulting information can now be accessed through structured rows and columns. This makes the dataset significantly easier to review, filter, analyze, and integrate into other workflows. This demonstration used a 100-page synthetic invoice specifically created for portfolio purposes. The underlying approach is designed for much larger document processing workflows and can be customized for different invoice structures, reports, logistics documents, financial records, and other complex PDFs. If your business has repetitive PDF processing, document extraction, Excel automation, or data transformation work that currently requires significant manual effort, a custom Python automation system can potentially automate much of that workflow. Thanks for watching.